Hello, good morning. Can you hear me?
Yes.
Okay, great. Only very few of us. Okay, we are joining. We'll start shortly. Okay, let's start. Hello once again. If you remember what we were doing last time we discussed in detail the feature generating procedure for our subsequent machine learning tasks. We discussed 5 different classes of features. Each of them might be a vector. So, for example, our liquidity taking and liquidity replenishment features, they may be related to different time periods or different decay coefficients alpha. So within each class, there are multiple possible features which need to be generated, right? So I think we discussed in sufficient detail how all those features, hopefully useful in our subsequent analysis, could be generated. I hope you remember all that. Do you?
Yes.
Okay. Okay. So today we need to implement one more critical piece before the actual machine learning task can be started. So, okay, features are arguments of the functions to be learned. Today we will talk about the functions themselves. So, what actually is to be learned, and what are the models we are going to fit, potential models we are going to fit using the features discussed last time. But before, from the point of view of feature generation, is everything okay? How are you progressing with your computational lab assignments? Have you managed to implement all those features we have discussed last time? So can you share your experience with me, please?
Well, as for me, I implemented not them all, but I did the biggest part of the spectra because it's very time consuming, very space consuming because all of spectras together weigh, for example, 60, 70 gigabytes. And
They're big. They're big indeed, yeah.
yeah, and we need to maintain several copies of such things because it's ambiguous whether we will use them or not. So yeah, the problem is space manipulation, and the algorithm is not that hard, but the problem is to like make it easy to compute so it's fast and it doesn't take much space.
You are absolutely right in highlighting the challenges. And actually, that's very typical. What you would really encounter in large scale, real life data mining problems. So, by themselves, the algorithms might not be that much complicated. If clearly formulated, they're, I think, easy enough to understand and to implement. But you really deal with large amounts of data, you generate large amounts of features, you need to do it in a reasonably efficient, let's say, one pass manner in order to save the computational resources. So technically it becomes, I wouldn't say it is a very, very major challenge, but it still requires, I would say, very careful implementation. And I hope you will be able to complete this task and to implement all the required features, because obviously we wouldn't be able to progress with our machine learning tasks if we have not collected all features. So for at least, let's say, a subset of instruments and a subset of dates, but we will need to collect all the features before we can go on and really implement our machine learning. So today we'll discuss our models and our machine learning objectives. So let me do the following. Okay, imagine the timeline as it was. So we are sometime t0 now. And as discussed, we have collected features at t0, and we're also using data from some previous time instance, which I denote by t minus 1, t minus 2, maybe eventually uh, t minus k, or indeed, if we use exponential moving averages, then somehow we incorporate all previous data, although with small weights. So the depth uh, from which we collect the features may actually be infinite. The feature space is finite, but I believe it should be perfectly clear. If your features are, for example, exponential moving averages corresponding to particular decay coefficients alpha, then effectively your feature set has an infinite memory and refers to market data with small weights, but nevertheless attributed to arbitrary times in the past. Is it clear?
Not
Yes.
really. Not like to me, no, not.
For you not?
Like not really. I didn't get how is it infinite and like the
Okay.
last part.
Okay. So let us examine it in some detail. So basically, if you collect features using some finite depth windows, as we discussed, so for example, you are using windows of certain length in order to compute market pressure or liquidity replenishment rates over those windows. So then your dependency on the past history is finite. So take the longest window and then you depend on the previous data at t0, t minus 1, and so on, up to some finite depth at the time t minus k. But if one of your features is your EMA, exponential moving average, with a certain decay coefficient alpha. So for that, you remember how you could do it. If you use EMA-based features, then, for example, at a particular time, let's say t0, you have, for example, some quantity q0, which is either quantity taken or quantity replenished, depending on which features you generate. Quantity taken on bid or ask side, all right? It doesn't matter, some quantity, or quantity replenished. Put into price levels, as we discussed, you remember, 1 to 5 on bid or ask side. With EMA, your feature, the corresponding feature you generate, let me denote it by F, would be the following. The current feature at, let's say, T0 would be equal to alpha times quantity Q0 plus 1 minus alpha your feature at time t minus 1. So you take the previous value of your feature with the weight 1 minus alpha, and you take the current value, let's say, of the quantity with the feature alpha. But at time t minus 1, there was a very similar algorithm of how the value at t minus 1 was generated. And it was f of t minus 1 in a similar way when we were at time t minus 1, alpha q minus 1 plus 1 minus alpha f of t minus 2. So now t minus 1 depends on eventually the quantity at minus 1 and feature of t minus 2, and so on. So you regress and regress and regress into the past. Any ft minus I was actually alpha q minus I plus 1 minus alpha f of t minus I minus 1, and so on. So when you construct this exponential moving average, then eventually the value of exponential moving average you construct depends on all previous features from the start time. There is no finite window at which this dependency stops. This should be clear from the recursion equations we wrote. Ft0 depends on ft minus 1 when ft minus 1 was computed in due time. It depended on ft minus 2 when ft minus 2 was constructed in the corresponding time. It depended on ft minus 3, and so on. So you have an infinite dependency depth.
How about we say that we have finite values in the EMA, but it has infinite capacity for the future because we didn't start from infinity before?
Well, yes. So obviously we start at some start time. So there is a start time here. Obviously it cannot regress to antediluvian times. Obviously that's true, you are right. But on the other hand, as time progresses, as time t progresses, your depth of dependencies in EMA becomes greater and greater and greater. So the principal difference between finite windows and EMA is that EMA has, I would say, potentially unbounded dependency history. It doesn't mean that it is truly infinite at each time, but it is potentially unbounded. Whereas if you use finite window, then obviously it is bounded, let's say, bounded by the window size. You are right. So it is more correct to say instead of infinite dependency depth, I would say potentially unbounded. Is it clear now?
Yeah,
So,
thank you.
yes, and we see this is probably one of the advantages of AMA because you don't need to maintain very large windows. You can do it in a very simple way, just algebraically. Your dependency on previous values, although it does exist, is diminishing over time because all those coefficients 1 minus alpha are less than 1, and eventually the contribution of historical parts become, distant historical parts become smaller and smaller and smaller until they become practically nil, but mathematically you still have theoretically speaking, dependency on the whole previous history. So okay, that's about our features. Once again, we'll need to be very careful in constructing the features, and once you complete them, hopefully, are you going to complete the feature set this week in a Thursday lab, or what are your plans actually?
The deadline for all the features is next week, so I guess most of us will
Next
finish
week.
by next week.
Next week, okay, great. That's fine. So it can be perfectly okay if we do it next week. Fine. And today we'll discuss how we're going to use those features. So we're going to use them in some kind of prediction, but it is important to distinguish between, I think, two different cases of prediction. And then after we have distinguished between them, maybe unify them in a single model. But before that, we will consider them. I think it would be quite instructive to consider them separately. So, in general, as we have already discussed, our objective is to construct a model for some algorithmic trading strategies. So that's the objective for all our learning. So what kind of models? Let's see. There are two major classes of, first of all, strategies and then the corresponding models, because they would depend on those strategies which you could implement in this case. So number one are market making strategies. You already know what it is, but we'll re-emphasize. Predominantly, there are different definitions actually what market making is, but for our purpose here, we would say predominantly based on passive order execution. And therefore earning the bid-ask spread. I think I have already demonstrated the examples of how it works, but we will revisit it today. And the second class, which is very important, and that's probably what comes to one's mind in the first place when we're talking about an algorithmic trading strategies. Market making is something which you need to know about before you come up with this type of idea, this type of strategy. What is immediately clear is that there are also market, let's say, momentum or trend-based strategies. They are quite dissimilar from each other, although eventually they can be integrated into one. Let us probably start with momentum, because this is very simple. it is very easy to imagine a momentum type of strategy. Using all information, all features we have collected at time t0. So at this point, you have your set of features, okay? Maybe we would use some other features apart from those discussed so far, but I think feature sets 1 to 5, which we covered in the previous session, are perfectly sufficient to begin with. So using all this information available up to time t0 in the momentum strategy, you make a prediction about the future price movement. So this is, for example, USD ARB price. So you make a prediction whether it is going to move up or down based on your information. And based on this prediction, you take either long position, if your prediction is up, long buy USD ruble contract, or short sell USD ruble contract in order to write on the predicted trend. And obviously, indeed, if you buy it and you are right, the price goes up, then you sell with the profit realized at some future time t0 plus 2, for example. So that's your time horizon. If you predicted the trend correctly, you buy your contract here, you sell it at a higher price, or you short sell it. I think I have mentioned what it means. Short sell means you sell it, but you don't have it at the moment. You sell something which you don't have. So how short sell works, in most cases it does. So the exchange allows you to do it. You take a short position, anticipating the future fall in prices. So you don't have a USD ruble contract in your portfolio. Nevertheless, you sell it to someone, but you don't need to deliver it immediately. As we discussed, you remember, any trades which occur during the trading dates are only indications of the future capital movement. The actual settlement occurs and movement of funds from one account to another, they occur only at the end of the trading session. And the end of the trading session is, for example, for USD ruble, is after 17:30 for today's contracts, and even after 17:30 tomorrow for tomorrow's contracts. So if you sell USD ruble, it doesn't mean that you need to deliver it to your counterparty who bought it from you immediately. What you do instead, you may sell it when you don't have it. At time t0 plus 2, the price falls, and then you buy it back from the market at a lower price. So you received higher price when you short sell it at t0, and then you really get it because it will need to be delivered eventually. You actually get it from the market or close your position at time t0 plus 2, but at a lower price. So at time t0 plus 2, what happens is that your position is 0, so you don't need to actually do anything. Well, actually you do, because you have short sold it to counterparty A at time t0, and you bought it back from counterparty B at t0 plus 2 at a lower price. But your position, your net position is 0. So effectively, the contract will be moved even bypassing you from counterparty B to your counterparty A. Whereas what you would do, you would receive the delta. So for example, how short sell works. The price was, let's say, 75 here. You predicted through your model, that's why we're talking about prediction, that it is going to be 74 at a later time. At T0, buy from A, sell to A at 75, but do not deliver immediately. Sell to A at 75. That's how short sell works. But do not need to deliver the dollars immediately. At T0 plus 2, buy from B at 74 and then deliver to A. So obviously your profit equals to $1 in this case, because you sold at a higher price than you bought it back. That's a completely normal market practice, which you have no doubt heard about, which is called short sell. And being able to enter both actually long and short positions is instrumental in this type of momentum strategies. So that's how trend following or momentum works. This should be perfectly clear, and the strategy is entirely based on the validity of your continuous prediction, right? So if your prediction is right, then you really lock in the profit due to directional movement of the underlying. If your prediction is wrong, then you suffer losses. For example, your prediction says the price is going to go up. You enter a long position, you buy your asset, but instead the price falls, and then at T0 plus 2, you are forced to close your position to sell your asset at a lower instead of a higher price. And instead of, let's say, $1 profit in this case, if it really goes up to, let's say, 76, then you suffer a loss of $1 because of the price fall. This simple by construction, but effectively based on machine learning and what we call continuous price prediction through machine learning strategy, is called momentum, because directional market movement up or down is called momentum. There is such a term. So that should be generally clear. Please tell me if there are any questions or uncertainties about the momentum take strategies. Is it in general clear how momentum works?
Yes, one thing,
Yeah.
T0 plus the sample you wrote buy from B at 75. I think it should be 74 to get the $1.
Oh yes, of course. At 74. Otherwise, we made the zero profit. Yes, and then buy back from B at 74. Indeed. So if we implement machine learning for the purpose of the momentum type strategy, then in the simplest case, we now specify what we want to predict. So the machine learning problem is the following. Given the feature set f at time t0, predict, what do we actually predict? What do we want to predict in this case?
We can either predict the next price or is it going to be higher or lower.
So in the simplest case, we can actually predict many things. We can predict, for example, predict the price at T0 plus 2. If we predict the price at T0 plus 2, so we get a value. We do some kind of value prediction. Then it is actually a regression problem. It is like, and indeed, you know, it can be done by mathematical machinery of linear or nonlinear prediction. So the outcome of our learning is the value of price. So that the value, regressed value at time t0 plus 2. That's one thing. Another thing we can predict is whether simply the price is going to be high or lower. Actually, even this simple example demonstrate that there are many things we can predict. Alternatively, we can simply predict a Boolean value whether price at t0 plus 2 is going to be, let's say, greater than price at t0. This is a classification problem. I'm sure you encountered in your machine learning studies, in your previous machine learning studies, you encountered both actually regression and classification problems. Is that correct?
Yes.
And actually, this classification problem can be binary, or it can be, for example, ternary. So classification could be if price is going to be greater than, less than, or maybe we would say approximately equal, which means undecided. So our classification problem may not be able in some situations to tell whether it's going to be a significant price movement, in particular because you remember that the prices cannot be arbitrary. The prices are all around the price step. So maybe the classification, our classificator says if only two state, then it is a binary, or if it is three-way, then it is a ternary classificator. So it may be essential to introduce the undecided or approximately same state, in which case you would not try to enter a position because either the predictor said that within its accuracy it is going to be unchanged, or even if the predictor said that it is going to change, maybe the change is so small that it doesn't warrant executing an order. In this case, you remember that placing and filling orders in the exchange, it does not go for free. You have fees which you need to pay to the exchange. They are not extremely large, but nevertheless, all those trading strategies need to take the fees into account, because it may very well happen that your trading strategy is specified well enough and it is on paper profitable without the fees, but when you really start executing orders and paying fees, then the fees simply take up a very significant part, or maybe the whole of your profit, and it doesn't work anymore. We will return to this point shortly. So yeah, there could be a classification like this. So taking fees into account, you are probably interested in not in just this type of ternary classification, greater than or smaller than or undecided approximately same, or you probably want a better classifier. You introduce some take profit threshold, or simply profit threshold. Delta, and you would be asking the following questions. You probably already know which. Where the price at T0 plus store is going to be either greater than price at T0 plus delta, not just greater, but greater than price at T0 plus delta, or it is going to be not just less than price at T0, but less than price of T0 minus delta, or otherwise price at T0 plus store is going to be in the interval price of T0 minus delta, price of T0 plus delta. So again, three cases, but we're interested not in just greater than, less than, or undecided, but you are interested in greater than by delta at least, less than by delta at least, or unchanged within the delta precision. This makes much more sense. And delta should be greater than for implementing your trading strategy. Delta should be greater than the fees you are going to pay. What kind of fees we will see in a second, because there is absolutely no point in, for example, taking a long position. Yes, suppose that your prediction is correct and the price at T0 plus store is going to be, for example, price at T0 plus delta, but then you realize the profit of delta, but then the fees from this transaction appear to be greater than delta. So your profit minus fees appears to be negative. There is absolutely no point in doing that. You would probably agree with this, all right? What kind of fees do we have? In Moscow Exchange, they really depend on your setup, which broker you use, how it is implemented. So they could be in the range from 8, that the absolute minimum, to let's say $30 per 1 million of contract size. I will explain what it means. So basically it means that relative fees are from 8 10 to minus 6 to 3 10 to minus 5. They are relative. So what does it mean, relative? Relative fees mean that if, for example, your buy or sell price, say, and that is for each transaction, by the way. That's important. Let me denote this fee rate by, for example, phi. Say you buy, obviously, you buy a minimum of 1 contract. And 1 contract is 1 lot is 1000 USDs. But suppose that it is just 1 per 1 USD. That's probably easier. So if you buy it you're trying to make profit at 75, then your fees are 75 times phi per each dollar. You sell at 76, you pay the fees again. By the way, once again, pay fees again, and fees are even greater in this case. It is 76 6 times phi, where phi is in this range based on your arrangements with the exchange or your broker. And believe me, there is a big difference between 8 10 to minus 6 and 3 10 to minus 5. Most of high frequency trading strategies would be quite profitable at the lower end of the fees, but they may become unprofitable at the high end, unfortunately. So altogether, unfortunately, you pay the fees of 151 times phi. How much is it? Suppose that phi, for the sake of the argument, is, let's say, 2 10 to minus 5, which is about the reasonable minimum you can get. You can get 8 10 to minus 6 only if you are a very, very, very professional institution in this case. So your fees are your P&L in this case. P&L is profit and loss. In this case, it is profit. It is $1. All right? It is $1. If you buy at 75, you sell at 76. The fees, total fees you pay, are in this case 151 times 2 10 to minus 5. Approximately, it is what? 300 10 to minus 5, which is 3 10 to minus 3, which is 0 0 0 3. In this particular case, sorry, no, I'm wrong. Your P&L is not $1. The contract is denominated in rubles. Apologies. So your P&L, if you buy at 75 and sell at 76, is 1 ruble. Okay? And the fees which you pay in this case are relatively small, so they appear to be 3 10 to minus 3 in this particular case of what? Of ruble as well. And they are of the scale approximately in this case. You remember the price step is one price step is 0.0025 rubles. So basically your fees in this case are of the range maybe 1.5 price steps. That's perfectly okay. And you see, they're negligible if you really made a profit of 1 ruble. You buy at 75 and you sell at 76. That's perfectly okay because your delta is large. So your delta is 1 ruble in this case. But in many high frequency momentum strategies, delta by itself may only be maybe some 4 price steps. 4 price steps is precisely 0.01 ruble, 1 kopeck, or something like this. So if your delta is so small, but you hope to receive your delta very, very frequently, then your P&L becomes already very much comparable with the fees. So your fees are, for example, 1 or 1.5 price steps, and that is taken from your profit of 4 price steps you earned. So for high frequency, low gain trading strategies with very small delta, taking your fees into account becomes very, very, very important. So you need to understand for how much price movement you aim and how much of that will be taken as fees. You may ask me, okay, let's not use so small deltas. Why should we use so small deltas? Let's aim for big deltas, such as, for example, one ruble, buy at 75, sell at 76, and in this case will be totally insensitive to the fees. They would become absolutely negligible in that case relative to your P&L. But unfortunately, we can't always do that. So let us discuss. I would like to hear from you. What do you think actually? Should we, in designing this type of strategy and correspondingly designing our predictor, should we aim for sufficiently large deltas, such as maybe 1 ruble? So we'll be predicting whether the price is going to be the current price plus 1 ruble, the current price minus 1 ruble, or we should use very small deltas, like in the latter case, delta is only 4 price steps, and in this case, it is 100 times smaller. Actually, it is only 0.01 rubles. So, what do you think?
I would say like the big deltas are hard to realize and less frequent and might not be very accurate because the market could change, while smaller deltas are fairly more predictable and we can do more of them because it's logical that the price can change in a small range more than the big range. So I think it's like a trade-off between them, like maybe something in the middle or like 4 price steps and losing half of the 4 price steps, but doing it like let's say 10 times per second could be very beneficial.
You are absolutely right. Absolutely right in your assessment of the situation. So big deltas, first of all, difficult to realize because they correspond to rare price movements. Rare means long tours, long tour horizons, those horizons, long horizons. And on long horizons, prediction becomes very difficult. I can give you a formula. How delta is related to tau. Approximately. For small deltas, we can, from the theory of stochastic processes, which can be used to model the price movements. I'm not going into details of how we demonstrate this, but from the stochastic process theory, we can say that a price movement absolute price movement, up or down, we don't know which way, absolute price movement in horizon tau is approximately equal to, by magnitude, to the following quantity. The current price, the bigger the current price is, let me ST being the price of time t. That's my notation. The current price times some approximately constant, which is called volatility, times, that's important, square root of the time elapsed, so square root of tau. So it is proportional to the current price, the volatility, what it exactly means we'll see in a second, and the square root of tau. So then if we really want to realize the profit related to the profit threshold of delta, we should say that delta itself would be approximately equal to, with up movement or a down movement, to a 0 sigma the square root of tau, which in turn means that tau should be approximately equal to delta divided by 0 times sigma squared. So increasing delta would require us, and that's important, increasing delta would require us to increase the horizon of our price prediction as a square of delta. And that's undesirable. Increasing it as a square of delta would mean exceedingly long and long and long horizons, but that's what we don't want to do. So now we can say more quantitatively, when we say long-term horizons, we say proportional to delta squared. What does it mean? This means that, and there will be one very important consideration apart from the fees which we need to take into account. Let's make some computations related to this formula. Tau is measured, what do you think, in which units the time is measured in quantitative finance?
Milliseconds.
It would be very nice in our high frequency trading, but unfortunately it is measured in years. I'm not joking, in years. And the values of sigma, which are typically known from the statistics of the corresponding processes is per 1 year. So you see that sigma is not linear in time. Sigma is basically per square root of time. And typically, let's say sigma, let's say a very typical value could be 0.2 year to the power minus 1/2. So multiplying this constant by a square root of time, again expressed in years, we get a dimensionless quantity, and then delta is proportional to the current as 0. So let's see what it could be. If it is per year to the power minus 1/2, then tau is to be, then tau is to be in years as well. This is a little bit unpleasant, but I think we can deal with that. So for example, suppose that we say delta equals to a very important question, actually, how to set delta. As a very minimum, not only our delta should be greater than the fees. We already know that the value of our fees is going to be 1 or 1.5, for example, price steps. Okay, suppose that delta is, okay, the fees, which is 1.5 price steps, plus delta should be greater than, plus what? How are we going to execute our orders in this type of strategy? You remember that there is a passive execution and aggressive execution. So either we cross bid-ask spread, and in that case we cross bid-ask spread twice, because first we buy, then we sell, or other way around. First we short sell, then we buy back. So we cross the bid-ask spread twice. And twice crossing would incur a loss precisely as one bid-ask spread relative to midpoint, if you remember. All right?
Yes.
You remember that. And the bid-ask spread is also about, let's say, those 4 price steps, maybe more, maybe 6 price steps. It is on average 1.5 copex. So plus bid-ask spread, and that's very important. And bid-ask spread is, let's say, 6 price steps. So that the minimum value of delta is already 7.5 price steps. That's the absolute minimum. Not only in this way you pay the fees twice, but you also pay the bid-ask spread effectively. Only you pay the fees obviously to the exchange. It is the mechanism of executing your orders. And the bid-ask spread you simply pay to the market. Basically, you pay the bid-ask spread to your counterparties who stood passive. You hit or lift their passive orders. And then in this type of execution, half of bid-ask spread comes from your P&L to them. They stand passive and they earn this P&L. You execute aggressive orders, and therefore you spend your bid-ask spread. So this happens in case of aggressive execution. You might ask, okay, I don't need to spend my bid-ask spread. I would place my orders passively in order to spend only 1.5 price steps and not to spend the remaining 6 price steps. This might be problematic because if you put your orders passively, then you are not in control of when they are going to be filled. You understand that, right? A passive order is completely at the mercy of the corresponding aggressor, who is going or not going to hit or lift your order. A momentum trading strategy is a trend-based strategy. So why would you, for example, buy at this point? Because your predictor shows that the price is going to go up. And that's why you would like to enter, for example, a long position and make a profit on the price going up. Fair enough. But you are not alone in the market. Probably some other people also have a similar type of continuous price predictors, and it may very well be that a significant number of market participants think in a similar way as yourself. So they all want to buy at this point. If they all want to buy, then the aggressions happen as lifts, you remember. So the aggressors come and cross the bid-ask spread bottom up, eating up the liquidity in the asks, in the lower asks part of the order book. If you place your order passively at the best bid, it may very well be that due to prevailing trend, it would take a long time to get filled, because most of executions occur on the opposite side. And by the time when your order is filled, the momentum is probably going to be over. So as a rule of thumb, not necessarily, but as a rule of thumb, I would say short horizon momentum strategies require aggressive order execution. You can't simply sit and wait until your order is going to be filled, because by that time your trend may very well be over. So yes, you in most cases do need to pay extra fees, in this case as a bid-ask spread related to aggressive order execution. You can't do it passively. Really, you can't.
How about like if we know, for example, the price will drop, so I will send out like we would do two transactions, like first before the prediction, one after the prediction. So how about the one before the prediction, we do it passively, and the one after the prediction, we do it aggressively, if the one before was executed actually?
It is a very good idea. So what you say may be a very good idea, let me put it that way, or at least or at least you may very well be right with that. Aggressive order in order to enter your position at T0, and passive order at T0 plus 2. At this point, you're really in a rush to jump on a trend. 1 second, please. 1 minute. 1 minute break. Okay, so a rush to jump on a trend, and at T0 plus 2, you can say possibly take more time, possibly you can, to exit your position.
But I was thinking of the opposite because it gives me a disadvantage, but like guarantees my profit. Like if I did passively first, so and it was actually executed, I can buy the aggressive later. It gives me the disadvantage that I might not be like fulfilled and not get the trend at all, but it protects me from the loss.
Or the way around, you say.
Yeah.
I would say it might be. It might be. But why I would probably recommend at least this way, because the time when to buy is dictated by our predictor. Our predictor says the trend is starting by now. You can't really wait to buy. If you wait to buy and you buy passively, then most likely, and that's what I was going to discuss regarding the market making kind of strategy, and I think we'll discuss it in more detail in the next lecture. If you wait to buy, then most likely it happens when the opposite trend starts. So basically, that the order book, you placed your passive order to buy here, and this order is going to be filled when a micro trend in the opposite direction. So people are starting aggressively selling, which means that your order is filled, but the price is going down. So you are really risking to get into the descending downward trend if you wait until your passive buy order is executed. This is a so-called adverse selection problem. So probably the timing of your orders is dictated by your signal. And your signal is what your machine learning based predictor is telling you. And that's why here by predictor signal, you buy now, as it says. Whereas whether you can exit your position in little bit more, I would say, slack time, not that much in a rush, is possible. Because typically exit times might be a little bit more extended, but still, if your price movements are just, like this a saw-like pattern, then, for example, your signal would tell you, your continuous price predictor would tell you to enter here, and then you really need to decide when to exit. If you simply exit by time, then you can do it at any moment, but ideally you would like to exit here, obviously, and you can't wait very long, because otherwise an opposite descending trend may start. So I think a semi-passive, semi-aggressive order execution might be possible in this case. Exploring this is in general a good idea. And in that case, so let's say fully aggressive execution, delta minimum is, as we say, 7.5 price steps. Semi-aggressive, if feasible, it may or may not be. Delta min is, therefore, then instead of 6 price steps, you spend only how much? You spend 3 and you earn 3, roughly.
I will be only losing the fees, right?
So you see, when you do an aggressive order, you spend half of bid-ask spread. When you do a passive order, you earn half of bid-ask spread relative to the midpoint. Therefore, if you do twice aggressive, then it is the whole bid-ask spread. But if you are one time aggressive, one time passive, then it is 0, because they counterbalance each other. So then actually you improve your profit margin significantly, because for semi-aggressive, your spread cost is 0. Once it is plus 3 minus 3. So as a result, delta minimum is only 1.5 price steps. And that is a very good idea. Whether it is feasible in this type of strategies or not, it depends. But in general, in both cases, I would say that you would need to, you need to make some profit out of that as well. So let's put delta minimum at 10 price steps. What is 10 price steps? It's not that too much. It is 0.1 price step is 0.025
Would be 2.5 cubic.
times it is 0.0025, because it is quarter over copper, times 10, and therefore it is just 0.025 ruble. That's 10 price steps. All right. Okay. How long is our prediction horizon? How long does it need to be in this case? As we say, tau is delta divided by S0 divided by sigma. So in this case, the characteristic time for which you need to do your prediction, tau, is delta, let's say, divided by sigma divided by S0, let's say 75 ruble. Sigma S0 squared, which is 0.025 divided by sigma is 0.2 divided by 75 squared, which is And you remember that is in years. So a simple computation says that you can check. Please compute. So
2.7 to the -6.
Let's see, 0.275 and squared. 2 point, yes, roughly 2.8, 2.8, 10 to -6 year. And then unfortunately, why we had to do it in years? Because our sigma is known in years. The typical values of sigma or volatility is computed in years, and that's why we had to use 1 year as a time unit, because otherwise we would need to recompute our sigma anyway. How long is it? Let's say that you can recalculate it into seconds, depending on whether it is a calendar time, I mean wall clock time, or trading time. There is a different number of seconds per year. If only trading seconds are taken into account, then, for example, if only trading seconds, then what does it mean? One trading day is very roughly 50K trading seconds, not 86,400, 50,000 one trading day. 1 year is again not 300 is not 300 not 365 days. One trading year is 250 in Russia trading days. The rest are various public holidays, well, weekends and public holidays. So 1 year is therefore 250 by 50K. It is 12.5 million trading seconds. That's a big difference. 12 trading seconds. And therefore, this would translate into canceling 10 to 6 and 10 to -6, 2.8 times 12.5, it is about 35 seconds. All right? So the time horizon which you will need to make your predictions for is 35 seconds in case if only trading seconds are taken into account, or if wall clock seconds are used. 1 year was 31 million, not 12.5, but 31 million seconds. And multiplying this by 31, 2.8 by 31, you get 87, roughly 87 seconds, or 87 seconds wall clock, which means that we got a very important result now. that our price predictor, our prediction must work with, let's say, 30, 90 second horizons at least. 30, 90 second horizons at least. Maybe for the smallest fee and smallest execution cost, if you do it half passively, half aggressively, maybe something like 30 seconds is enough, but roughly 1 minute horizon would be required for our predictor in this case. We will continue to examine this and build a model in the next in the next lecture next week. And although I can't promise 100%, it is very likely that we'll switch to face-to-face offline format from next week on. I really hope for that. But we're done for today. Any questions, please?
No, thank you.
Okay. Can you repeat? We will use 1 year as 12.5 million seconds or 31 million seconds when using Sigma.
It depends on how Sigma. It depends on how Sigma is defined. The Sigma itself is quite approximate. So
Well, I'll take our 0.2. To give an example,
let's use 12.5. Let's use 12.5. In which case, yes, a 30-second horizon is enough, but I would aim at 1 minute anyway, as some kind of just reasonable horizon we'll need to use. Let's say 1 minute is a good compromise.
I want to ask a question. In the market, how frequent does the update does the price update? Like,
the price updates.
Is it like continuous, or
you can see it from your data in prime time because you got all your data when you build the order books, so you can see that in prime time from 10 a.m. to maybe 3 p.m. when the markets are most liquid, updates occur, midpoint price updates occur probably with 10 millisecond interval, so about 100 times per second. Very frequent. 100 times per second roughly. You can really see it from when you construct the order book. You can compute the characteristic intervals between let's say your midpoint price updates. Late in the evening, it will be very infrequent, so it could be several seconds, maybe 10 seconds, but the prime time from the market opening at 10 a.m. to maybe 3 p.m. During the day for the initial 5 hours, it would be up to 100 times a second. Okay. And with that information, we would need to make predictions up to 1 minute for up to 1 minute horizon. That's the point. So effectively, this 1 minute horizon is required for the price to at least move for 1 bid-ask spread, something like that, and also for the amount equivalent to our fees. Something like that. We'll continue with this next time. Thank you.
I'm sorry, a couple of organizational questions. Does it mean that we get the full list of features next week, not this week? So we can have some time to develop these features.
Please continue the development of your features. Obviously, if you do get all of them this week, it would be great, because then we can start implementing our machine learning straight from the next week on. but I think we'll need one more lecture anyway before we formalize our model. So if you get them, let's say by Wednesday next week, and then Wednesday or Thursday you start implementing your machine learning, then it would still be okay. It's still not too late.
Okay, and another question, what about our midterm grades? How's it going in general?
Sorry, about the grades.
Yeah, like how the process is
They will
going.
be in model very shortly this week. Yes.
Okay, okay, thank you.
Thank you. Thanks.